So, before we really look at this protein issue and get a little bit more into the actual nutrition, I wanted to talk about that first stuff first, so that we can eliminate all the little excuses that we all carry around in our heads. It's my age, it's my metabolism, it's childbirth, it's my genetics, it's my zip code. I've actually had somebody say it's aliens. None of these things are important. They're definitely factors, but they're not important. You are in charge of how many calories go through your teeth. It can't end up here if it doesn't go through here. You're in control. So let's look at how to make that control work for you. What's important to know about protein? Well, we'll talk about some really kind of anal specifics, but proteins are just chains of amino acids. Are you familiar with that term, amino acids? Get a picture in your head a bicycle chain. You know, all those little links combined together, and they happen to be formed into a shape and a structure that's useful for something, a transfer of energy. So you've ridden a bike before. So amino acids, just imagine those little links to be different shapes. And whatever combination of sufficient quantities of these things get put together, and we form things called proteins. So you have one kind of protein that's your hair. It's a kind called keratin. You have another kind of protein that's the clear coating on your eye, your cornea, and a whole other one that's the palm of your skin. And I don't know, 40 or 50,000 of them, I'm just making up the number, that are the various hormones and enzymes in the body. And there's a bunch of different uses for protein. All of them are made up of amino acids. And we, like I had something to do with this. In science, we talk about various kinds of amino acids by either being essential amino acids or non-essential. Now, I'm only going into this so that you can simplify some of the stuff that you read about. Essential, anytime in nutrition you see the word essential, it just means that the body can't make it, so you have to consume it. So do we get a lot of essential amino acids from vegetable sources? Get a lot of essential amino acids from broccoli? Not so much. Generally speaking, what makes animal source proteins more efficient, which we'll talk about in the next slide, what makes animal source proteins more efficient, or you get more use out of a smaller amount of protein, is that bike chain that we were talking about, more of the links are essential amino acids. Non-essentials can be manufactured by your liver from the essential aminos. The only reason I go into this is some people ask me about, well, what about soy, or what about a vegan diet? Are you familiar with that term, a vegan diet? Someone who's a vegan won't eat anything that was ever part of an animal. I actually had a client 3 years ago who was a fruitarian. I had to look it up. I'd never heard of that thing. 17 years at that point of training, a fruitarian is someone who won't eat anything that had to die. So if you eat the fruit, the tree's still alive. Does that make sense? Can you imagine how hard it was for this person to actually live in a semi-healthful way? I couldn't work with them on the nutrition side. There was nothing we could do. To lose weight, they were losing muscle. There's no way around it. Because it's not like there's a lot of fruit with a ton of protein in it. It just doesn't happen. All right, so essential amino acids are really what we're looking for primarily from foods. And the body uses these amino acids to rebuild your tissues, to rebuild the muscle, to add hormones, to add enzymes to your body. These things that I'm discussing right now relate back to that equation, calories in versus calories out. The construction of these molecules burns a bunch of calories. It's a very significant portion of what's called your basal metabolism, or your RMR, your resting metabolic rate, how many calories you burn at complete rest. All right, and all proteins, regardless of source, are approximately 4 calories per gram. So coming back to that equation of calories in versus calories out, soy protein, whey protein, chicken, beef, all right about 4 calories per gram. But how useful they are is a whole different thing. So this is what's actually happening when we eat. You remember when phones had that funky cord? Remember the twisted little springy cord? And if you were like me as a teenager, you kind of paced while you were on the phone, and by the end of the phone call, it was this nasty little knot you couldn't unwind. So now you couldn't walk away from the phone. Maybe that's just my house. I had 2 older sisters, an older brother, and me, and my parents were ecstatic when the cordless phone was invented. I ask about that because that's kind of what a protein looks like in nature. You get that bike chain, that chain of amino acids, and then it gets all wrapped up, knotted, and twisted up on itself, kind of like that drawing. You're never going to find a protein drawing that actually looks like that, but that's the idea, artist representation of a protein in nature. So relate this back to food. You know, with some white fish, it's very flaky and very light and very tender. You know what I'm talking about? It's got that very light tooth feel to it. The knot of its proteins is fairly loose. Imagine it more like a pile of feathers. It's fairly loose construction. All the amino acids aren't really close together. Versus free-range bison. It's much more dense, right? Each bite you have to, I hope nobody's a vegetarian and I'm really freaking you out right now, but when you bite into it, it takes a little bit more pressure. The amino acids are much closer together. It's significantly more dense. So that's a protein in nature, and we start breaking that protein down with the chewing process. We start to denature it, is the term that's used. So really, we're straightening that protein chain out and exposing it to the enzymes and acids in the stomach so that the bonds between the amino acids can be broken. So you can take those links that are making this chain and separate them. So now you have separate links, or maybe 2 or 3 links are still stuck together. We call these mono, di, and tripeptides, sometimes polypeptides. Not an amino acid anymore. You don't have a bike chain anymore. You couldn't stick this thing on your bike and pedal across town. You could throw them at your bike and dent the bike. But they're not stuck together anymore. It's not a protein anymore. I want you to get that. It was a protein. In the stomach, it no longer is a protein. The proteins are broken down. Very rarely is there an exception. If a whole protein actually makes it into the intestines and through the intestinal wall into the bloodstream, the body recognizes this as an invading bacteria or virus and attacks it with the immune system. Hormones are proteins. Proteins, while ingested, go through the stomach and they get broken down. They're not proteins when they get to the intestines, and even if they are, they're invaders. And they get attacked and broken down. Every study of every single time for the last 15 years, even those paid for by PETA, which is the most well-funded organization trying to prove this to be true, shows that hormone levels are not elevated in Americans. It's not happening. But we are seeing earlier onset puberty. That's a whole different discussion. As you'd imagine, I have an opinion about that, but it's not this class. So we have these proteins in nature. We begin breaking them down into these into these mono, di, and tripeptides and polypeptides. And in the intestines, these things are absorbed, and they go into the bloodstream, into the liver. In the liver, we reconstruct them into proteins based on the phrase is called the homeostatic need of the recipient. There's a quiz later, so you should write that down. All that really means is your body gets to choose how it gets to be used. So this morning, almost everybody in here got destroyed with some workout. Whether it was your own workout or it was Keith or I responsible for abusing you today, you got abused. Your muscles are screaming for amino acids to rebuild from all that destruction. Literally, every time you exercise, it's like your body's a brick wall and you're beating the heck out of it with a hammer. You're breaking that wall up. And so it requires proteins and carbohydrates and fats and vitamins and minerals to rebuild that wall. Well, the amino acids, the proteins, that's the bricks. If you don't have enough bricks, you lose muscle, despite all the effort. You don't want to lose muscle. So right now, even though your body is just raging for all those proteins to rebuild your muscles, if you walked out of here, God forbid, knock on something, you walk out of here and you trip and fall and rip open your leg and you're bleeding all over the parking lot, what is a bigger demand for the body? What's more important, rebuilding that quadricep from the 4,000 lunges you had to do, or fixing the hole so you don't bleed to death? The hole, absolutely. So what's the body going to use the protein that you ate for dinner to do? It's going to fix the quad or fix the knee? It's going to plug the hole, homeostatic need of the recipient. Now, I go into this only because there's a lot of advertising out there saying this kind of protein does this and this kind of protein does that. We don't get to choose that. We eat it, let the body do what it's going to do. The only way that that could be different is if you actually took the protein and applied it. It doesn't work that way. Plus, that'd be kind of gross.